compound inequalities are just two inequalities stuck together. So if we look at the statement 4 less than x less than or equal to 6, it really means that 4 is smaller than x and x is smaller than or equal to 6. We just stick it together with the x in the middle, squished between the 4 and the 6. So we can do compound inequalities and solve them the same way we solve linear inequalities. We just want to make sure that whatever we do to one piece, we do it to all the pieces. So this says solve the compound inequality, graph the set on a number line, write your answer in interval notation. So what we notice is that in this compound inequality, I'm trying to solve for x. So I have to try to get x by itself. To do that, I need to subtract 2. Whatever I do to one piece, I want to do to all the pieces. So there are 3 pieces to this compound inequality, so I'm subtracting 2 in 3 places. Negative 4 minus 2 makes negative 6, less than or equal to 3x, less than or equal to 18 minus 2 makes 16. Again, I'm trying to get to that x right there, so I want to divide by 3. Whatever I do to one part, I have to do to all the parts. Because the number I'm dividing by is positive, I don't need to change anything. So negative 6 divided by 3 makes negative 2, less than x, less than or equal to 16 over 3. So on a number line, I have the negative 2, I have the 16 over 3. I want to squish the x in between there. I want to put an open circle at negative 2 because it's a strictly less than, and a filled in circle at 16 over 3 because it's a less than or equal to. When I write it in interval notation, I start at negative 2 and I end at 16 over 3. Negative 2 didn't have that equals, it has that open circle, so it gets a parentheses. 16 over 3 gets a bracket because it has the less than or equal to and that filled in circle. So that was a compound inequality where the x was stuck in between 2 things. I could also have a compound inequality where there's sort of 2 things that could happen. 2x minus 5 is less than negative 11, or 5x plus 1 is greater than or equal to 6. When I get something like that, I'm going to solve each inequality separately and then graph them on our number line together. So I'm going to begin by solving this first inequality. Add 5 to both sides. So 2x less than negative 6. I'm trying to solve for x, so divide by 2. X less than negative 3. Remember, you only flip the inequality if the number you divide by is negative. So since I was dividing by a positive 2, I don't need to switch anything. Okay, now I'm going to go back and start the other inequality. So subtract 1 from both sides. 5x greater than or equal to 5. Divide both sides by 5. Again, that number I'm dividing by is positive, so I don't have to switch anything. X greater than or equal to 5. So I'm going to put both of those things on the number line at the same time. So I need negative 3 and I need 5. I want the x's that are less than negative 3, so these, with an open circle here because I don't have an equals there, less than. And I want the x's that are bigger than or equal to 5. So those, and I'm going to put a filled in circle at 5 because I have that equals. Remember, that side is positive infinity, the left side is negative infinity. So I have 2 intervals. Remember, when I have 2 intervals, I'm going to put that u in between them. So my first interval goes from negative infinity to negative 3. I use parentheses there because I have an open circle at negative 3. My second interval goes from 5 to positive infinity. I use a bracket at 5 because I have that filled in circle at 5. Remember, infinity and negative infinity get parentheses no matter what. So there's 2 sorts of compound inequalities you might see. And you solve them exactly the same way you've been solving all the linear inequalities.